Hey, so picture this. I'm sitting for this certification exams for AWS, and I crammed the night before, reading through hundreds of pages of AWS services, IAM policies, CloudFormation, best practices. You know the drill. I felt pretty confident that I've absorbed so much information. Fast forward the next morning, I'm staring at a complex question and my mind just blank. All that information I crammed, it's gone. I could not remember anything. I could remember bits and pieces, but not the specific details I needed to properly analyze whether a particular policy configuration was secure or not. So I finished the exam thinking, if only I could have referred to the documents. I knew this stuff was in there and I just couldn't remember the exact details when I needed it. So fast forward now to this landing zone accelerator diff logs analyzer application. I've just built this application and I ran into the same exact problem. The log analyzer came with this AI assistant to help analyze AWS landing zone accelerator diff logs. But when I asked it important questions, it was like me when I did not know how to answer the exam. The LLM could give general advice, but couldn't access specific details from the actual log files. So today, I want to share how I solve this by adding RAG capabilities to my LZA analyzer. Basically, giving my AI assistant an open book exam, and the results are great. But first, let me show you the problem I was facing. This is the contents of one of the log files. There's hundreds of them. I just wanted to show you how the AI assistant answered my questions before I added RAG capabilities. So here's the version of the application before RAG. When I asked it what specific IAM changes were made in the dependencies stacks, look at the reasoning section. This is the key for me in understanding its reasoning. The AI is basically saying, I don't have that information and I can't give you a proper assessment. Just like me in that exam, it's being honest about not knowing the specifics, but that's not very helpful, is it? And it goes on further to say that it must strictly reference the provided files, but it can't give any other answer because it can't access those files. That's because I've designed the system prompt to be very strict. The AI must only respond based on data it actually has, not make assumptions. But clearly, something fundamental is missing here. The AI needs access to the actual log content, just like I needed access to the AWS documents then. Now, let's have a look at how the AI assistant answers the same questions after I've updated it with RAG. So the first part is the reasoning, saying that it noticed there are 5 documents, which is correct, and it further reasoned that those log files all have the same structures, and it further realized or determined that I was giving it instructions on string to array conversions, that they're just structural changes. They're not substantive changes. So all of these were instructions I've given the assistant. So the final answer is that it's saying that because there's only a string to array conversion in that particular section of the IAM policy change, which is really just the addition of these square brackets here, that is really just a change. It's adding those square brackets to make it into an array from the original format of just one string, and there's no addition of any other principals or permissions. In the end, it says they're non-substantive formatting updates, and really there's no security risks being introduced by this change. So that's a very good answer. It was able to know about the contents of the relevant log files. So, how did I transform my AI from that cramming student who forgot everything to a well prepared student with full access to the reference materials? RAG is the answer. Let me explain RAG using my exam analogy because it's sort of what has happened. Okay, so let's start from the left, where the user poses a question to the LLM. The LLM refers through a vector database, which in the analogy is searching through a reference book using index and table of contents to retrieve that relevant info, and using the relevant information and the original question, combining them, which is the augmenting part of the retrieval augmented generation, giving that to the student, and me then being able to provide that informed answer with citations and references. So RAG is essentially giving my AI assistant an open book exam for every question, augmenting the prompt with relevant data from my own log files. Now, let's break down how this open book exam works behind the scenes, because it's more sophisticated than just handing someone a pile of textbooks. First, I need to organize my reference materials. I can't just throw entire log files at the AI. We needed to give it this chunking system so that it can split particular sections of the log files. If we look at the example log file here, I first broke it down into what these IM statement changes are, because it doesn't know about these ASCII tables. Then there's a section about the resources, the minus to the pluses. So it will know about the stack sections, resource changes, and if there's been any modifications to any templates. Think of it like creating perfectly organized study notes with clear chapters, sections, and subsections, making sure related information stays together. Much better than just giving it that whole document, which it has no idea how the particular sections are related and split. Next comes the indexing system using embeddings. Traditional textbook indexes uses alphabetical order or page numbers, but think of embeddings as having that additional understanding on concepts and meanings. For example, if you're looking for information about IM policy, the indexing with the embeddings will know to look for access permissions as well, security roles, and authorization rules, because they're conceptually related, even though the words are completely different. And I use the model called All Mini LM L6v2, which converts each section of text into a numerical representation, which is a vector that captures its meaning, like having concept-based bookmarks instead of just page numbers. So all these intelligent bookmarks get stored in a database. It's specifically a vector database to store the vectors. I use ChromaDB, which is like having a librarian who understands context and meaning, not just exact word matches. Unlike a regular textbook index that only finds exact words, this system can find conceptually similar content. If you ask what IM changes were made, it doesn't just look for the exact phrase IM changes. It finds the sections about permissions, policies, roles, and access controls. So these three boxes here at the top stores the data into a vector database for the LLM to be able to obtain that information when it needs to. That is the retrieval part, which is this second part down here. So when it comes time to answering a user question, it uses this hybrid search methodology where it searches for the exact words as well as semantic similarity. If there's any similar concepts that IAM changes, for example, not the exact words relate to, it will retrieve it from its vector database, which is the log files that we've given it to convert and put it into a ChromaDB, which is its vector database. And there's that retrieval process, which gets that information, both exact keywords and semantic similarity. Then it sends it back to a process of combining the original question as well as the additional relevant information from the log files, making that into an enhanced prompt that finally the LLM processes, where it is able now to give that informed answer, which is this conclusion here. The IAM changes are non-substantive formatting updates, and there's no security risk being introduced. I'll just quickly go through the code. This is the chunking system. So it's obviously named. It's looking for the metadata. This one is chunking for file content into the logical sections. Few methods in there, parsing through the sections, chunking the section, extracting the IAM statement chunks. This is the vital part for us. Those tables, making it know where each table starts and ends. And there's that concept of overlapping as well, so that those chunks, separate chunks that are contiguous to each other, have some overlap. Extracting some more metadata like the account IDs, regions, the stack names. This is the embedding and retrieval system. So we have our LangChain RAG system, initializing the chunker, initializing the diff files. This is the bit where it retrieves the context. The hybrid search, which has search for exact keywords as well as semantic search using LangChain again. I built this using LangChain because I learned about it from an excellent free course at Deep Learning AI, which I'll link in the description. Thank you to the people at Deep Learning AI for making such high quality education freely available. So the beauty of using LangChain is that it handles the complexity, managing the embeddings, the vector stores, and retrieval chains. It's like having a pre-built study system that just works. What's next for me? This RAG implementation has transformed my AI assistant from useless because it didn't have any information that it can tap into to be able to provide a useful advice to something now that can provide me the advice that I'm after. But there's more improvements that I've noticed I have to make, because I've noticed that the AI doesn't remember previous parts of the conversation. If I ask it, is this change good or bad for my environment, even though it's already told me that those IAM changes did not pose any security risk, its response had nothing to do with the previous response. So it's like having a conversation with Dory from Finding Nemo, that it didn't remember anything that it told me in that previous response that I've asked it about. So that next challenge in itself will involve a few techniques and concepts that I'd like to experiment and play around with, and I'm looking forward to that. So building this RAG system has taught me so much about how AI systems work and how to structure the data for the AI assistant to retrieve, and how to build applications that solve actual problems. The best part is I'm learning by doing, making mistakes, and sharing the journey. Thanks for watching, and I'll see you next time as I tackle the conversation memory challenge.